Hello there, welcome back to this video. We're going to be looking at how to describe what the motor effect is. Now, before we get to do that, we have a few questions to have a quick recollection to what we did last time. Now, what happens around the wire that carries current? That's the first question. Second question, how to find the direction of that thing that occurs around the wire? Now, you need to describe which hand rule, how to use the hand rule in this case. And question 3, draw the direction of the field around these two wires. So we've got two wires here, we've got this one, and then we have this one, so you need to draw around it. Now, if the current were to be increased, what's going to happen to the field around it? Again, now pause the video, have we got these three questions, and once you're ready, let's come back. Okay, so let's pause the video. Have we got these four questions, and then come back. Okay, so I'll assume that you had a pause of the video. Now let's take a look at that. Now, for the first one, so we have a wire. Let me draw a piece of wire like this. So the wire is going up. Okay. Now inside the wire, what we have current flowing in the wire. So let's say current is going upwards in this case. Okay. I'll label this I for current. So current is going up in this case. Okay. Now when current is going up through the wire, now there's something being created around the wire, and this something look like this, a circular pattern being created around it, and this here is the magnetic field. Okay, so magnetic field created around a wire that carries current. Okay, now you can actually see the pattern is circular. Now the next question is, how do you find the direction of that thing? So how can we work out the direction of the magnetic field? Now here is a hand rule. So the hand rule, okay, or like I call it the thumb rule. Okay. So this here is your right hand. Yeah. So you're gonna need your right hand. Okay. So how does it look like? Let me show you. So you got your thumb. Okay. Your thumb. The thumb shows direction of current. Okay, your thumb shows direction of current. Okay, and then this is your right hand, of course. So let's have a look. And then what you have is you have your curl of your fingers like this. Okay, and the curl of your fingers. So you use red. So the curl of your fingers like this. The curl of your fingers. So this show direction of the magnetic field. Now let's apply this to our diagram. So we have the current that's going up, so therefore the thumb is going to be pointing up. Put a tick there, and then the curl of your fingers. So the curl of fingers in this case is what? So what is this movement? So this movement is clockwise. So therefore it's going to be turning clockwise. So therefore it's going to be turning this way. So here we go. Because look at the curl of your fingers. The curl of your fingers is pointing this way. So therefore we're going to turn this way. Clockwise. Here we go. Clockwise. So that's how we can use it. Now we're going to use it again here. So which direction is it showing in this case? Again, so I'm going to do, let's take this down here. So we got the dot, and the circle. Now when you have a dot and a circle, what does it mean? It means that the current, okay, is going out. So the current out of the screen / paper. Okay, so the current's going out. So therefore, what's going to happen? Your thumb is going to be pointing to the outside. So the thumb, let me see whether if I can draw that. So your thumb will be pointing this way. Your thumb will be pointing this way, and then your curl, your hand is going to be pointing this way. Okay, so this is the thumb. So your thumb's pointing out to you, and then the curl of your fingers pointing this way. So therefore, with the curl of fingers, again, I'm going to be using circles. The magnetic field is in the circle. Magnetic field is in the circle. So it's going to be pointing this way. So therefore, it's going to be clockwise as well. Here we go. As you can see. Now let's do the second one. The second one is cross. If it's a cross, it means that the current is going in the screen / paper. So in this case, okay. Now again, we are going to be using our right hand rule. So how would it look like this time? So our thumb will be pointing in the screen. So look, pointing in the screen. Okay, and then our hand will be pointing like this. Okay, so like this, I think. Yeah. Okay, so the thumb is pointing in the screen. So our thumbs, and then our fingers go this way, so you can clearly see. So therefore, we're going to have circles around it. This is how the magnetic field look like, circle, and therefore the field points anti-clockwise. Here we go, anti-clockwise. Okay, so that's how we use our right hand rule. Sorry. Okay. Now, if we were to increase the current, so if current goes up, so I increases, then what's going to happen is the magnetic field around it. So let me just draw the dot. Okay, so 1, 2, 3. So again, you can use your right hand rule to find out the direction. So the direction will be going this way, this way, this way. So if the current increases, it means that we're going to have more field lines, and they're going to be closer together like this. Okay, so therefore we're going to have more field lines. Okay, so more magnetic field lines. They'll be more dense, so more of them. Okay, so this is the answer for the do now. Again, so make sure that you got everything in your book before we are going to be moving on. Okay, all right, nice one. Now the next thing is we're going to be looking at is a, where is it? Before we look at the motor effect, we're going to be looking at a solenoid. Yeah, so a solenoid. So this is something that we may have not covered yet, but we'll find out. Now a solenoid is just a curl of wires, wire. Okay, so we take a wire and then we coil it up. So let's have a look. So we've got a wire and then we coil it up. So we've got 1, 2, 3, 4. Here we go. So we've got a coil of wire. So I'm going to draw the wire like this. Here we go. Here we go. Okay, we've got the coil of wires there like this. Now let me just see if I can. Okay. So let's do it like this. Here we go. Coil of wires. Okay. Now in the wire, we're going to have current going through the wire, of course. So I for current. So current's going to go through that, through the loop down here, 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 and here. Okay. Now one thing I need to note, I need to add a coil of insulated wire. Okay. So for it to work, you need to be insulated wire. Okay. Otherwise, it will not work. Okay. Now what we want to do is we want to draw the magnetic field around the wire. So the magnetic field is going to look like this one here. So in the center of the solenoid, the magnetic field line will be, okay, let me just use a much, going to look like this. So straight line in the middle, here we go. Straight line to the middle. Okay, straight line to the middle, straight line to the middle. That's 1, that's 2. Okay, because what we have is we have current that is flowing in the wire. So this will create a magnetic field, but the thing is, since it is curling up, so it's going to generate a magnetic field that will go like this. Okay, let me see whether I can put a fourth one here. Okay, so here we go. Now, what's going to happen is you look at the direction of the current. The current is going in this way, the current is going in from the back, and the current is leaving from the front. So therefore, the back is going to be the south pole. The back would be the south pole, and the front, because current leaving the front, this will be the north pole. Okay. Now what we're going to do is we're going to be looking at how the magnetic field line looks like. So the around is going to look like a bar magnet. So therefore, this here is going to go all the way across here. Okay, as you can see, this one will also go across here like this. Okay, and this one will go like this here, and it's going to go like this here. Okay, and the direction will be from north to south. Okay, so to south. Again, from north, leave from north, goes all the way to south. So leave from north all the way to south. So leave from north all the way to south. Okay, so I'd like you guys to make sure that you have this down in your book. So this is how it looks like. So inside the field, it is uniform. So you can see it is uniform inside the field. It is uniform. Okay, so just go through. It is uniform like this, but outside it looks like a bar magnet. So you can see north to south. Okay, so this is the solenoid. Okay, good. Okay, now we are ready to look at the motor effect. Okay, so motor effect. Okay, now let's break it down for you. So what we have is we have a piece of wire like this. Okay, in the wire we have current flowing through it. Let's say current going this way. Okay, so current going this way. Now, what's going to be created around the wire? So we know that a magnetic field, which is circular, is going to be created around, the wire, like this. Okay, right. And can you tell me which direction is going to be? Again, we're going to be using our right-hand rule. So we've got the thumb pointing this way. Okay, pointing this way. Here we go. So therefore, the curl of your fingers is pointing this way. So therefore, it goes like this. Okay, so here we go. So this is how it looks like. Okay. Now we have wire that has current in it. This creates a magnetic field, isn't it? So we got this one. Now, what if we take this? What if we take this? Let me have a quick check. Okay. So let's say current goes this way, and then let's say we have two magnets. We have a magnet here. So this is the north. Okay, and let's say we have one here, which is the south. Okay. Now, what is in between these two magnets? So we got magnetic field. So the magnetic field goes from north to south, north to south, north to south. So what we've done is we've taken the wire that has current in it, that this creates a magnetic field around it. Okay, and then we place this wire with a magnetic field between the magnetic field of these two magnets. Now, what's going to happen is the wire will experience a force, and the wire will end up moving, downwards. Okay, let me have a look. Delete. The wire will end up moving downwards. So the wire will end up moving downwards. Okay. Now this is pretty much what the motor effect is. Okay. All right. So here is the explanation. Okay. So when a conductor, so in this case the wire, okay, or a coil of wire. Carries current. Okay. Alright. It creates a magnetic field around it. Okay. Right. So now, when that wire is placed inside a magnetic field of a permanent magnet. Okay, you can see here permanent magnets. 4 points. Okay, the magnet plus wire experience a force. Okay. Right now, since the magnet is fixed, yeah, so in this case the magnet's fixed, so the only thing that moves is the wire, so therefore the wire moves. The wire moves. Okay, the wire moves. Okay, the wire moves. Okay, now what we want to do, okay, the wire moves. Okay, now let's take a look. Wire moves, let's put it this way. Okay, now let's take a look. So, oops. Okay, so the force increases if, so the force increases, the force by which the wire moves increases if the current increase. So if we increase the current, if the current increases, therefore the force increases. Okay. Number 2. Okay. So if strength of magnetic field increases. So if we make the magnet stronger, it means this magnetic field will be stronger. Okay. Third one. Okay. If the length of wire, so see here we have one single piece of wire, but if we increase the length of the wire between the magnets, if the magnets increases. So these are the 3 ways in which we can increase the force. So if we want to make the wire move faster or more, we increase the current, or we increase the magnetic field, or we increase the length of the wire inside the magnets. Okay, that's how we do. All right, excellent. Now, so this here leads to an equation. So this here leads to an equation. Okay, and the equation is the following. So force equal to magnetic field strength, okay, multiplied by current multiplied by the length of wire or conductor. Okay. Now this one here, they can also call it magnetic flux density. So how dense is the magnetic field density? So they can call it like this. Okay. So therefore we can have the simple form now. We can have F equal to magnetic field is B multiplied by I multiplied by L. Okay. So this equation here is given, you just need to use it. So it's given, you just need to know how to use it. Okay. Now in terms of units, so we got force is measured in newtons, of course. Now magnetic field strength or magnetic flux density is measured in Tesla. Okay, so capital T, Tesla, capital T. Current, you guys know it is in amps. Length is going to be in meters. Okay, now if you're looking for the triangles, then the triangle is going to be F on the top, B, I, L, and here we go. There we go. F bill. Okay, nice one. So here we go. That is the motor effect. Now what we need to know is not just how to describe the motor effect, which is these 4 points here, how to increase the force, how to use the equation when we need to, but there's also a hand rules. Okay, so there's also a hand rule. So we're going to do it here. So we're going to introduce ourselves to. Okay, so Fleming left hand rule. Okay, now we use this. So this is the left hand. So we use this when we have three things. So three things. So when we have the magnetic field, okay, of magnets, yeah, that's one. Two, when we have current, okay, with currents, so on. Three, when we have force. Okay, right, now let me show you how it looks like. Okay, here we go. And this is what we need to remember how to use. Okay, right, so let's zoom in. Okay, now the thumb shows the force. Where would the wire move? So this is the force. Okay, the index finger is a magnetic field. So this index finger, you're going to have north to south. So this is F, where it's going to move north to south. Now your index finger is your current. So this is I. Now notice that all of these three fingers, they are perpendicular to each other. Okay, perpendicular to each other. Okay, so make sure that you do have this down in your notes, because we're going to be using this rules there. So if we want to work out the direction, where would the wire move? Okay, then if we know so let's say we know the magnetic field, we know north to south, we know where the current is pointing, and then we need to work out the force, we can use this. Okay, or vice versa. So if we know where the wire is moving, if we know the direction of the current, then we can work out the direction, where's the north, where's the south. Okay, and likewise, if we know the force, if we know the magnetic field, we can work out this direction of the current in. Okay, so make sure that you copy this down. Okay, and then let's take a look at one of the example here that we have. Okay, let's take a look. Which one do you have? Here we go. I have this one. Alright, so let's look at one of the example. Okay, here we go. Example. Okay. Okay, so example. Example here. Okay. Okay. Now, question telling us where is the force pointing. So where is the force pointing? Now, first of all, what you need to do, you need to align yourself. So first of all, you need to align yourself with it. Here's a diagram. Here's my hand. Okay, the left hand. We need to align ourselves. Now, what do we know? We know that this is north to south. So I'm going to align this first. So north to south. Here we go. Let me align this properly. Okay, just bear with me. Alright, anyway, let's do this. So now, the north to south. So the index finger is pointing in the right direction. So north to south. You can see north to south. Okay. Now, the current here. So this one shows that the current is going in the screen. So therefore, the index finger need to be pointing the other way. So I need to flip my hand. Let me see whether I can do this. If I can flip the hand. So I need to flip my hand. So you need to move the wrist in a way. So you need to move the wrist in a way that your index finger is pointing inwards. So therefore, you're going to end up with something like this. So you're going to have your, okay, so you're going to have something like this. So you're going to have your finger, index finger pointing like this. Okay, have your finger pointing like this. Okay, okay. So your index finger will be pointing inwards. Okay, like this, inwards. So sorry, this is the index finger. Okay, wait, I'm messing around. So this is north. Oops, there we go. So north to south. Your current will be pointing in, and then your thumb is pointing up. Okay, so your hand, you need to move your hand. So see earlier, your hand was like this. Okay, but we need to move. So we need to move the middle finger. We need to move the middle finger so that it is pointing inwards now. So that is pointing inwards. So how can we do this? You move your wrist. Yeah, so your wrist, you move your wrist. So therefore now we know that the current, the force F is pointing upwards. So therefore in this case the wire. Okay, my bad. My bad, sorry. I made a mistake there. So north to south. Yeah, so this is wrong. North to south. So it needs to be north to south. Okay, my bad. Let me just fix this again. So my bad. So north to south. Okay. So north to south. So therefore the index finger needs to be pointing like this. So north to south. Okay, and then I have my like this. Okay. So therefore the index finger will be pointing like that inwards, and then your thumb will be pointing like this here. Okay, so yeah, for your hand's going to be something like this. Okay, here we go. So you have your thumb like this, your index finger. Okay, so your index finger like this. So this is your index finger, north to south, which is correct. So north to south, which is correct. So north to south, which is correct. The current is going into the screen, so therefore this is going into the screen. So in the screen, therefore the thumb points downwards. So therefore the wire is going to be moved down. So the four points downwards. Therefore the current is going to be moving down. Okay, so therefore we know where the wire is going to move. Okay, so you can see you can make the mistake just like I did. Now let's do one more. Let's take a look. Which one can we do? Let's do this one. Okay, so let's do this one. Okay, let's have a look. Here we go. Let's do this one. Let's do this one. Okay, so here it's the same situation. Okay, so north to south. So we need to work out which way will it move. Which way will it move? Okay, so let's use our hand this time. Which way will it move? So again, so north to south. I'm gonna have my index finger. So north to south. Okay, now the current's going out of the screen. So it's dot. So therefore it's going to be like this. Okay, it's going to be like this. So I've got my fingers there, fingers there. Okay, so therefore the thumb is going to be okay. So here we go. All right. So yeah, I didn't draw this properly, isn't it? Okay, so thumb's there. Let's put the nail there. You can see that. There we go. Right. So north to south. Now current's going out of the screen. So going out of the screen. Therefore the thumb points up. So F points up. So therefore the wire is going to move up this time. Okay, here we go. Nice one. Okay. Alright, again, if you're not sure, we need to do more practice on this. Now, let's do another one so that you guys can have the sense of it again. So as I'm going through the video, make sure that you're trying to use your hand in this case, yes, so you have some practice. Okay, here we go. Now, this time, what do we need to do? Now, this time, we need to work out the direction of the current, so we need to find out the middle finger, so middle finger. Okay, now let's see what we got. We got north to south, okay? We got the direction, so therefore, we're looking for the middle finger. Okay, now let's take a look. Okay, so north to south. So we start with the index finger first. So let me just draw it here. The index finger. So north to south. So north to south. That's your index finger, yeah. The index finger. Okay. Now the thumb point downwards. So therefore the thumb needs to point down. How do I know if the thumb point downwards? Look at the arrow. So F is the arrow, so it's pointing downwards. So therefore the thumb needs to be pointing downwards. So therefore it's going to be downward like this. Okay. So therefore you got this one. So therefore the middle finger is pointing like this. Therefore, the middle finger is pointing like this. So therefore, the current is going out. So therefore, the current is going out of the screen. So therefore, it's going to be A. So this will be a dot. Let me draw it. This will be a dot. But the current is pointing outwards. So here we go. Current's going out. Okay. So this is the only movement of your hands where everything makes sense. Okay. Now let's do one more. So this way you should be able to be confident for now. Okay. So here we go. Now this time what are we doing? Okay, now this time we're looking for north and south. So we know that the current is going out. Okay, we know it's going up, so the arrow is going up. Now we need to work at north and south. Okay, so now we're going to start with what? We're going to start with the thumb. Okay, now start with the thumb. So thumb going up. So this is the thumb going up. Okay, now middle finger. Okay, so thumb's going up. So thumb's going up. Middle finger going this way. So going out. So this is my other finger there. Okay, and then so therefore the index finger will point this way. So therefore north to south. So therefore this will be north. This will be south. Okay, because this is the only way that makes sense for it to work. Okay, here we go. Nice one. Okay. Right. Let's do I think one last one. Let's see what we've got here. Okay. Now, how about this one? How about this one? What if we have something like this? Okay. Now, first of all, what is this diagram? What is this? Now, this shows you that here the current is going out. So current going out. Current going in. So what's going on? So this is actually a coil of wire. So it looks like this. So you got the wire that goes like this and then comes like this. So you got current. Here we go. So this is what happens. So the current's going in this way. So therefore going in, and then current coming out this way. Okay, so you've got a loop, a coil of wire. Now let's take a look what we have. So what we're going to do is we're going to do one bit by bit. Okay, we're going to do bit by bit. Okay, now let's do the cross one first. Okay, so we have north to south. So let's do this one first. Yeah, so we've got north to south. Okay, we've got north to south. The current's going in, so therefore the index finger is pointing in. Index finger pointing in. So therefore the thumb points down in this case. So that's something like this. So therefore you have like this. So therefore the force moved down. So F moved down. Okay. Right. Let's do it this way now. Let's do it this way. Okay. So let's do it for this one. So we're doing for this one now. North and south again. So north and south. Okay. So current is pointing outwards. So current's pointing outwards. So I have the finger like this, pointing outwards. So therefore the thumb point upwards. So this is my finger there. Point upwards. So therefore the current, sorry, the wire move upwards. So here the wire move upwards. So you can actually see in this one, what's going to happen is the wires start to move because one side move up, the one side move down. So you have a circle movement there. So you have a circular movement. So it spins. So this is where it's going to spin. Okay, this is where it's going to spin. Very, very nice. Okay. Now remember. Okay, so this is pretty much the motor effect. So this is where we started the motor effect and everything there. So make sure that you do have everything. Now once you're done, there's a worksheet which I posted on Google Classroom. So make sure that you get this done. Thank you very much.